So here we have a grammar that represents some made-up language, kind of a cross between, I don't know, Python and JavaScript. It has a lot of keywords that are found in a lot of languages. So let's say we add a new rule, and the question we need to answer is whether adding this new rule to this grammar creates an ambiguous grammar. As a reminder, an ambiguous grammar is one that, given a string in that language, there are two parse trees, there are two ways to traverse the grammar and create that string. As we'll see later, this is really bad for languages that we want to interpret, because it can result in the situation where one string, one program, one HTML document has two valid meanings. And so you can't really choose one. And that's not what we like. We use these precise languages, such as HTML and JavaScript, so that we know exactly what we want to be displayed or the exact actions that we want to be performed. We don't want ambiguity. Computers don't handle ambiguity very well. Their little brains explode. So we can sit and stare and think about this for a while, but I'll just give you an example string that actually shows that adding this rule makes the grammar ambiguous. I guess it's a check. So let's go over that. So here I have the string. And what we need to do is show that there's two ways using this grammar to generate the string. So one way is using the if-then-else construct, where this if, this then, and this else match here, here, and here. I mean, this part of the string corresponds to the C. This one goes here, and this one is from the E right there. That's one way to do it. A second way is using the if-then, do these two symbols, and then the if-then-else here, meaning that this corresponds to that S, this corresponds to that E, and then we have an if-then-else as that S. So here's two valid ways using this grammar to generate the same string. This shows that the grammar is ambiguous when we add this rule. Let's do another. Let's say we add this rule. B goes to a B and then a B. This is also ambiguous. Let's say we have print 4, semicolon, print 4. So now we have two ways to create this. One way is to start with a B. From there, we go to S and B. From here, we can do print 4. We can replace the B. Oh, I forgot to add that. We replace the S with the print 4. An alternative way is basically do something very similar, where we start with the B, we go to BB, but this time we replace each B with the S semicolon. So that's our second way. Here, there are two more rules, and neither of these rules makes the grammar ambiguous. When we add the keyword int, this is the only way to get an int, so there's not going to be a second way to generate strings with the int. And the same basic logic applies to the parentheses as well. This is the only way to add parentheses, and there's not going to be a second way there. All it does is add parentheses on the outside of a statement. And we can do it as many times as we want, but given X number of parentheses, you just apply this X number of times. Not a whole lot of fancy stuff going here. The fact that they match also is kind of a key contributor to this. If you had a parenthesis on one side and you had another row with the other side, then you could probably, maybe get some ambiguity depending on how you word it, but that's how this is. Let's go on to the last one. So this should look familiar, and I believe we went over this in lecture, something very similar to this, and this is definitely ambiguous. And I'll come up with one example. Say we have 1 plus 2 plus 3. We can do this in two ways. We have E goes to E plus E, goes to 1, and this eventually goes to 2 plus 3. An alternative way is that we have the 2 on the left-hand side, and then we have the 3. Although the meaning of a plus, the associativity of addition, allows us to do it in any order, from the perspective of a language of strings, perspective of determining whether or not the context-free grammar is ambiguous, the meaning of a plus is irrelevant here.